Consider the coefficient of x to the 6 in the expansion of the following. Right? We have already seen these polynomials. I'm not going to read out all of them, rather explain all of them. You all know what are these polynomials. We had earlier stopped up to 1 plus x to the 4, so on. I have just continued till 1 plus x to the 5 plus x to the 10, so on, into 1 plus x to the 6 plus x to the 12, so on. Right? Now, how do I get x to the 6 coefficient here? Well, before that, let us take a look at the partition of 6. This one, 1 plus 2 plus 3, right? How do I get 1 here? It is equivalent to taking a x here from the first house because I have only 1, 1. I have just 1, 2, therefore I'll select a x square here, and 1, 3, therefore I'll select a x cube here, right? And x into x square into x cube will give me x to the 6, right? That is equivalent to the partition 1 plus 2 plus 3. Now, how will I get x to the 6 if I consider the partition 1 plus 5? 1 corresponds to picking an x from the first house. We have only 1, 1, and 1, 5 represents picking a x to the 5 from the fifth house, right? There is only 1, 5, and hence it is x to the 5. Now, what does this represent? 6. It is directly picking x to the 6 from the sixth house, right? 6 is equal to 6. We have only 1 6, and hence it is equivalent to picking x to the 6 from the sixth house. Now, what if I take 2 plus 4? We have already seen this. It is equivalent to picking x square from the second house and x to the 4 from the fourth house. Each is x square and x4. The reason is because we have 1, 2 and 1, 4. Right? We have already seen this. Now, the question is, look at this. PD of 6 distinct partitions I was addressing all this while. Right? We saw 2 plus 4, we saw 5 plus 1, 6, 1 plus 2 plus 3, and so on. Right? We have seen these 4 partitions of 6. All of them were distinct. And I showed you how do we get an equivalent of x to the 6. How do we? By multiplying x square, x cube, we got x to the 6. Similarly for the other partitions as well. Now, when you take a summand k, either it is present or it is not present in the partition. Right? You chose one, either it is there or it is not there. And this happens, what does the statement mean? Either it is present or it is not present. It means, since we are addressing distinct partitions, it does not repeat, right? So either it is present or it is not present, and it is the same for all the summands for any k, and therefore it is represented as 1 plus x to the k. The function is equivalent to writing 1 plus x to the k, right? So the generating function for PD of x is given by 1 plus x into 1 plus x square into 1 plus x cube into 1 plus x to the 4, so on. And therefore PD of x is product of I from 1 to infinity 1 plus x to the I. Right? I hope it is clear to all of you. If I take the summand 2, right? Then the corresponding generating function will be 1 plus x square. Now, corresponding to 3, it is 1 plus x cube. So, the generating function for PD of x is 1 plus x into 1 plus x square, so on. This product will give the generating function. Then, what is the coefficient of x to the n? PD of n is the coefficient of x to the n in the expansion of 1 plus x square, 1 plus x cube, so on up to 1 plus x to the n. Box this and keep. It is very important. We have earlier seen how do we get P of n as the coefficient of x to the n. Now, in particular, we studied how do we get the coefficient of x, that is PD of n is the coefficient. We have got more stronger observation now. PD of n is the coefficient of x to the n in this product. You might want to watch the video once or twice more for better understanding.